Today's recording is going to cover OpenShift using CIS with a big IP cluster. So this is the third video in this series, and this video is specifically focused around a cluster of big IPs front-ending this OpenShift 4.7 cluster. And so what I want to demonstrate in this video is some of the recommendations on what to do with the F5 big IP front end in this OpenShift, and some of the requirements and the specifics that you have to configure to basically get this to work. A couple of things that are really important before we get started. In this series, this is still using big IP cluster with OpenShift SDN. So OpenShift SDN is using the VXLAN here. So big IP is part of the CNI, and this VXLAN tunnel is established between the big IP and the Kubernetes cluster. That's really important. OpenShift has changed, or is in the process of changing, its CNI to OVN Kubernetes. That is going to be the next video. However, we're going to be doing and covering more of a hybrid model. And the reason is because OVN Kubernetes may not 100% be ready in 4.7. So we're going to get there. But as we get there, these are the different options. So 4.7, F5 CIS, big IP cluster, it's pretty stable with OpenShift SDN. OVN Kubernetes is to come. So what you can see here is that you have two big IPs, big IP 60 and big IP 61. If we take a look at big IP 60, you can see that it's running active, and big IP 61 is a standby. And so anytime there's an update, both big IPs would get updated because each big IP has a instance of CIS. And so that's really important. Big IP is not necessarily manually, its big IP is manually syncing, but CIS only knows about one big IP. CIS at this point, at least in CIS 2.0, CIS is not aware of the big IP cluster. And so what happens is that CIS can learn the route and configure the route for its associated big IP. So that means that any specific time, each big IP in the cluster will have the appropriate route information and therefore can forward the traffic to the associated pod. What's really important is that only one big IP is active for the data plane. So both CISs are active for the control plane, but only one big IP is active for the data plane. And so that's really important. So let's take a look at some of the prerequisites. So in this environment, I'm using OCP 4.7 installed on VMware using this installer provisioned infrastructure. It's really cool, actually. It's super simple. It's running on a ESX host that is configured in VMware vSphere. I'm using 6.7, and all of the masters and workers are provisioned in the VMware data center / cluster using this installer provisioned infrastructure, or IPI. I'm not going to go into it in too detail. There's a great YouTube video from a user that created or that guides you through this process if you want to use OpenShift 4.7 on vSphere using IPI. He covered it really well, so I'm going to go ahead and leave it there. One thing that I am using is I am using CIS 2.5, which is a new version coming out in the middle of July 2021. I'm also using the new version of AS3. It doesn't really matter as long as you have one of the latest versions of AS3. 28.29 is pretty updated. I'm also using version big IP 16.x. So let's take a look at some of the prerequisites. We have to have AS3 installed on big IP. AS3 is the API that CIS uses to communicate with big IP. So CIS communicates with Big IP across the AS3 based API to actually push the configuration down. So once we've taken a look at the prerequisite, have AS3 installed, the first configuration item that we have to do is that we have to create the tunnels because we're using VXLAN. And so in this case, we have to create a profile. So I've basically provided a configuration here within Big IP to create that profile. So if we take a look at the Big IP and go down to the network, take a look at the tunnels. And so what we actually have to do here is actually create this tunnel. But to do that first, we need to go to tunnels and we have to create the profile first. And the profile that I'm using in this case is the VXLAN profile. And in the VXLAN profile, I've created this one. This is just a name. I call it multipoint. This is what I've done here. So with that command, I've created this profile called VXLAN MP, which is in common. It uses the VXLAN protocol. Multipoint is really what it is. And it's using the following port number, 4789. 4789 is a UDP protocol for VXLAN. It has to be bidirectionally open between Big IP and the OpenShift cluster. So if you have a firewall, you have to have it open for both Big IP to OpenShift, OpenShift to Big IP. Make sure that it's open or you're going to run into problems. So that one command creates that profile. Then I reuse that profile later on. As you can see, I'm reusing the profile name when I create this policy. And this policy is really important. So I create this, you can call this policy profile, but here's what I'm creating in the next step. I am creating this tunnel with this name called OpenShift VXLAN. It's key 0. You cannot change the 0. It has to be key 0. Key 0 is SDN for OpenShift SDN. If you're using Kubernetes, it's different. But in this case, it has to be key 0. You cannot modify it. Here's my profile name we talked about earlier. And then there's something called local address, and there's something called secondary address. This might be a little confusing. And this is what's really, really, really important. The local address is the floating address, because the floating address is where you're going to tie the data to. The secondary address is the physical address. So think of the local address as the alias. It's the floating. And the secondary is the physical. And that's really important to understand. So as you can see here, that is my floating address. That is my local address. If I go back to Big IP and take a look at my self IPs, you can see my external, physical, floating. It's really important. Physical, the floating is part of the traffic group. It's really, really, really important to get that right, or else this thing will not work. And it's associated to traffic group 1. Here is the second tunnel on the second device. Here again, the local alias floating address 62. It's the same as above. It's the floating. Secondary, the IP address of the secondary. So if I access that machine, go down to network, take a look at the self IPs, you can see right here external. That is the self IP of the external system. And there is the floating. That's really important to get that right. Once you get that right, there are a couple other things that we need to start taking a look at. So that's how you create the tunnels. One thing that is really important is once you create the tunnels, later on, how do you notice if these tunnels are working? Well, you have FTP entries. These are tunnel forward database entries. They are basically, think of them as zip codes. They are forwarding traffic into the nodes. These represent all of the nodes in Kubernetes. It's a three node worker cluster and a 3-node master cluster, and this is what you see. Because Big IP is part of the CNI, it's going to establish an overlay communication with these nodes. And then from there, these nodes can route traffic accordingly. So it's really important that we have our FDB entries. CIS will update these FDB entries. That's what CIS will do. CIS will update Big IP with all those FDB entries. So it's really important that you get that right. The second step, because we're using OpenShift SDN, we have to create what we call a dummy node or a node within the cluster as part of the CNI. So we create this fake thing called F5 server, and F5 server has its physical address and is also part of the subnet. So what that means is, almost think of it as an extension. It's a self IP that is part of that network, and the reason why we create that self IP, so we can route, so we know, so Big IP knows about that network. So we're creating think of it as a node or a fake network or a network in OpenShift, so that OpenShift can route to these networks. And so that's what we're doing here. We're creating something called F5 server, F5 server 2, and F5 server float. These are the 3 networks that you need to create. This is, again, we talked about this is 60, 61, and this is the float. These are the physical IPs, and here are their appropriate subnets that are created in OpenShift. So let me give you an example of where these are. Based on my GitHub repo, you can find it here. And if we go into one of them, there is the host IP. It's real easy actually in OpenShift. All you have to do is just clone this. You do need to use the new API version. If you're using an older version of OpenShift that's maybe below Kubernetes 119, 120, you might need to use the old API version. But if you're using 4.7, you need to use these new API versions for Kubernetes 120, 121. So make sure that that's correct. But here is an example. Here is host subnet 1, and then of course we have host subnet 2, host subnet 3. So you need to create these in Kubernetes according to my documentation. So OC create these 3 files. You can clone them. What will happen is that you will have these 3 files of the physical self IP and of course the float. And now you have the subnet range or the CIDR that you can pull to create the self IP. And so that's really important. So the next step, or step 3, is to create the self IP for the VXLAN CNI. And so this is because Big IP needs to forward traffic because of cluster mode. Big IP is forwarding traffic to the pod. So it needs to know how to reach that pod, so it's got to be part of that pod network. And ARP is really important. ARP has to resolve across this pod network. So to do this on Big IP 0, we can do something called create self, and in this command. So here's what's really important. So if you take a look at the first Big IP server 01, and if you see here, it has 129.4. So Big IP, the first Big IP is this one right here, server 01. And so server 01, I got that subnet. So I need to create a self IP on 10.129.4. And so that's what I've done. I created something similar to the last octet. I've created 10.129.4.60, and then I've given it a /14. The /14 is interesting. But this is the reason for that is because this is by default. This is flannel. This is flannel pod network by default. So to be honest with you, unless you want to change flannel to a different subnet, which I wouldn't recommend, I would just stick with this /14. It will work for you. So by default, the system creates the subnet, but what I'm doing is I'm creating the /14 for the self IP. And so I'm creating an IP address on BigIP in that subnet with that mask, and that's what I've done here. So 4.6, I've created 4.60. I've created that one, and I've also created one for the secondary for 02, and I've also created one for the float. Only the master needs the float, because the master will configure the standby. So what will happen is when you create the float, you can sync the devices, and then the float will be on both. So you can see the float is 62. So 31.4.62. So if we take a look at the self IPs, we can see 131.4.62. There is the one self on traffic group 1, and there is the 4.62 on traffic group 2. So it's on both machines. That's because it's synced up. And so you just incrementally or manually sync it up. And so that's why you only need to do it on the master. So now both systems are available with that float. So that is the difficulties, to be honest. That right there is maybe what's a little bit complicated. It's a little bit more complicated in Kubernetes, but because OpenShift's a little easier. OVN Kubernetes, way easier. But that's to come in video 4. The next thing we need to do is we need to create a tenant. This tenant is really important because this is what CIS is going to use to manage the partition. So as you can see, OpenShift is my tenant, and what will happen is all configurations will get created within that tenant. So CIS is only writing and communicating to BigIP in the OpenShift tenant. Anything else, it won't access. It won't communicate with. And so that's what's really important. Now we're going to go ahead and configure the CIS instance. So in this case, I wanted to actually use the operator as part of what you saw in video 1 and video 2. Video 1, if you haven't seen it, it's part of the, just go to look at my YouTube channel or take a look at Dev Central YouTube channel, and you'll see video 1 was installing using the operator. Video 2 was installing standalone using the operator. Unfortunately, in this video, I kind of hit a bug, and this has to be fixed. And I'm talking to my dev team to resolve this. But in this bug, I cannot create 2 instances within the operator. There's a conflict within the CRD, and so the dev team needs to fix it. So unfortunately, I have to use manual. What does manual mean? It's not a big deal. I just have to deploy the deployments manifests by themselves. And that's a shame, because it would be nice if I didn't have to do that. And so if we look at the deployment manifests, if I go take a look at the CIS here, if I look at the 2 deployment manifests, here's the first one. And so what's really important in the deployment manifests is really just these arguments. These arguments are basically saying, here's my BigIP URL, here's my OpenShift partition, I'm using cluster mode. This is really important. It's common, and then OpenShift _ VXLAN. That is pointing to the partition for the tunnel. Right there. That is what that's pointing to. Common / OpenShift VXLAN. That is what CIS needs to communicate with BigIP to publish those FTP entries, those ARP entries, etc. It's really important to get that right. We're using routes. This is the virtual IP 1.65. We can see this on BigIP. if I change to the tenant, and that's 65 for both port 80 and port 443. Same virtual. We are working on multi virtual IPs per CIS instance. If you're interested in that, please reach out to me. I'm pushing to get that done, hopefully in an up and coming release. And then of course the debug. Here's what's really important. Make sure you install from this registry. We're using OpenShift, folks. Let's not install from Docker. Let's pull the image from the Red Hat registry. Because we do a lot, and we don't need to the image is on Docker. It's very easy to put the image up on Docker. But we go through a lot of channels, testing, regression, scrutiny to get this onto Red Hat. So let's pull the image from Red Hat. And so that's what's really important. We don't really want to pull from Docker. But it doesn't really matter. It's the same image. They're both the same based UBI file. But I'd recommend from a trusted source, I'd recommend to use the Red Hat registry. And so that's how you pull from the Red Hat registry. And so now that we have both of the installs, both of the CIS instances installed, you can actually see it. So if you want to validate it, you can go into Red Hat and you can go down to your deployments and you can change it to kube system, and you can see here's the one and there's the other. So both of these deployments are deployed. And so that's pretty easy to do. It's pretty easy to deploy it. Really, that's right here. That's the deployment. You need to create the cluster role. So these are a couple things that you have to do. These 5 things, if you're doing this manual, you have to do these. You have to create the user ID in Kubernetes secrets or OpenShift secrets so that CIS can access BigIP. It has to be the administrative password. There's no other way. Because of the way that the API is set up and because we're using AS3, requires it. There is your service account. There is your cluster role binding. The 2 deployments of CIS. And in this last one, this is new with OCP 4.x. If you don't create this ADM policy, CIS will not be able to detect the route. It'll be quite frustrating. It'll just sit there and you'll be like, what's going on? Everything's configured, but my route's not getting configured on my BigIP because you're missing that one last OC ADM policy. So just copy this. And it will work perfectly. Then you can go ahead and install the app. And so here I've created a route. If we go and access and do a OC, oopsie, sorry. OC get route. We can see there's my one route. And what that route is, let's take a look at that route on the dashboard. If we go to networking. So I've already pre-deployed a route, and it's in default, and you can see here's the route. This route has been accepted. If I click on this, there you go. It's super quick. And so, and this is active on the active BigIP. But both BigIPs are configured because each BigIP has a CIS instance. So as you can see, that route is deployed for mysite.f5 demo. If I wanted to fail this over, I could go to this guy and change this to common and force this to standby. And standby, and if I refresh this guy, he's become active. And so as you'll notice, this guy's become active, and I can go in and I can update, or I can select this to make sure that my traffic patterns are working correctly. I can select this link, and it might take a few minutes just to ARP and to connect. It should connect no problem. There we go. Connects no problem. So as you can see, I failed over. So now this is your standby. This is your master. And the app works perfectly fine. And so what I can also do is currently right here with my route that is created, I have 4 of these apps. What I can do is I can scale these apps. So if I go to the deployment, this is the deployment of these applications. What I can do is I can click on here. There's 4 of them. And why don't we make it 8? There's 8 of these deployments. If I go to the, you should see it on any big IP. Even the standby. Look at that. Right away we've seen it. Right? So we can see that the change has happened. And here the change has happened as well on the active. So if we go into the active pools, change to the tenant, go to the active pools, pool members, there's the 8. And if I can sync that quickly, I can manually sync that. And that will sync across. And that both in sync now after the change. Remember, anytime there's a change within OpenShift, both big IPs are going to show they're out of sync. And we're doing manual sync just because we don't know how many changes. So highly recommend manual sync. But every time you're going to get an update in Kubernetes, you're going to see out of sync. That's really important to know. So let's go ahead and recap. This is a series of OpenShift 4.7 demos using CIS as well with the user guide. So clone my user guide. This specific video is focused on Big IP cluster. The last video was standalone. So in this case, I have 2 Big IPs, Big IP 60 and Big IP 61. They're configured as a cluster, manual sync. They each have their representative CIS. So CIS 01 points to Big IP 60. CIS 02 points to Big IP 62. They both monitor in the same route. So when the route is created, both of the big IPs get the configuration. However, only one big IP is active from the data plane. So, and that's because we're using the float. So once you fail over, the float follows the active big IP. If you let me know if you have any questions. Let me know if this video is useful. If there's any more information you want. I know everybody's looking for OVN Kubernetes. It's coming. Hopefully by the end of next week or the week after that, we'll have the first video of OVN Kubernetes for hybrid model with OpenShift 4.7. 4.8, we're going to probably start getting more into OVN Kubernetes with Geneva tunnels. But for now, we're probably going to start just using hybrid. And that's basically the information that we're getting from Red Hat. Really appreciate the time. If you like this video, then please like or subscribe. I really appreciate it. Thank you so much.